Now things get a little bit more complicated when instead of putting numbers into functions, you start putting variables into functions. So here we have f of g of x. So first we're putting x into g. And what happens when we do that? Well, since g of x is 2x plus 7, then f of g of x would be the same as f of 2x plus 7. And then we have to replace every x now with 2x plus 7. So f of x, right here, is 2x squared plus 1. So f of 2x would equal 2x plus 7 squared plus 1. So what we're doing is wherever the x was, right, because it's 2x squared plus 1, that's what happens when you plug in an x. Now if you plugged in a 3, you'd have 2 times 3 squared plus 1. Now what we're doing is we're plugging in 2x plus 7. So that replaces where the x was. It's going to get squared times by 2 and add 1. And now we could leave it like this because that is an explicit equation, or we could multiply it out to see what it looks like.
Would you ever have to multiply it out?
Well, we do have to find its domain and range, and what kind of, this is going to be in x to the 4 graph. So for the range, we'd have to probably go to our calculator. So if we wanted to figure out domain, the domain is easy because there's no non-permissible values here. You could plug in any value of x. Another thing, well, this isn't a parabola, so we could multiply this out, complete the square, and find the vertex without our calculator. Remember doing that from grade 11? No, you're just shaking your head. So you like that so much. And then you have to, well, you could put it in factored form, or you could, like, that's where you can, do you want to see the completing the square just to remember it? So here we've got y equals 2. If I multiply this out, I'm going to get 4x squared plus 28x plus 49. I still have the plus 1 there. And times in everything by 2 will be 8x squared plus 56x plus 98 plus 1. For completing the square, you would factor out this first 8 out of those two. You still have 98 plus 1, 99 outside here. And then you would have to add a number inside so that it made a perfect square. Okay. This number here was always half of that number. And when you divided this by 2 and squared it, you'd add 49 over 4. But adding that 49 over 4, you can't just do that to one side of an equation because then it's no longer equal. So we would have to compensate for that. And what have we actually done? We've actually multiplied that 49 by 4 times by 8, which would be 98. So I'd have to subtract 98 to compensate. Because then what I did in this first blue line here is I added 98. So if I subtract 98, it's like I've done nothing. But then that changes this equation to this form, and you know that your vertex is at negative 7 over 2 comma 1. So that'll help us figure out that our range is y is bigger than or equal to 1. For this one, they'd probably let you use a calculator to figure it out. You could also see it from here a little bit, that if you plug in, did I make a mistake somewhere? negative 7 over 2 to get the smallest this will ever be is 0. Does that make sense? That the way that it's written right here, if you just analyze this section, the smallest this highlighted part will ever be is 0, because you're getting a number squared is always going to be 0 or positive. So if the smallest this ever is 0, and then you add 1 to it, the smallest this whole thing would ever be is 1. Yes?
But could we not also like read that it's almost in its vertex form because you just factor out 2 and would get x plus 7 over 2. Therefore,
In this part here? Yeah, and you could see that that would be what would make it 0, right?
and when we factor out the 2, we would square it and get the 8 in front of it.
Mm-hmm.
And have x plus 7 over 2.
Yeah. Okay, so there's A. For g of f of x, well, f of x was equal to x squared plus 3x. So you could replace the f of x with x squared. Did I take the wrong one for b? Oh, I'm taking the wrong equation. F of x is 2x squared plus 1. Thank you. There we go. So if f of x is 2x squared plus 1, and g of x, before we had g of x is 2x plus 7, so that means whatever you plug in to g of x, it gets multiplied by 2, and then you add 7. So now we're plugging in 2x squared plus 1. So that's going to get multiplied by 2, and then you're going to add 7 to it. So the explicit equation here is 4x squared plus 9. This one's a little bit easier to see domain and range. Again, there's no non-permissible values, so any x value is possible. And think back to our transformations unit, the very first unit that we took. What's happening to this parabola? It's getting stretched by 4 and then moving up 9. So you could see that its vertex will be here at 0, 9. And so the range for this function is y is bigger than or equal to 9. Okay, I want you to try C on your own. Put up the answer in a second. And the questions you can do for this are 10 and 11. How are you doing on C? Do we have an answer already? Or do you need a little bit more time? What did you get for an explicit equation for C? For x plus 21. Yes? And can you see that that's a line? So its domain would be everything as well, and its range would be everything.